Hi, I'm Dr. Hackie Reitman. Welcome to another episode of Exploring Different Brains. And today we have a returning guest, and I'm so honored and excited because it's my good friend, Dr. Bankole Johnson, who is one of the world's authorities on addiction, but a million other things because he's a real neuroscientist. He's head of that whole brain consortium at the University of Maryland. He's also a good writer, too, but we'll discuss that later. Cole, welcome.
I'm so pleased to be here. Thank you for allowing me to come back.
Are you kidding? And to have you right here live at our Different Brains headquarters is a double honor.
Oh, thank you. I'm so grateful to be here. And it's really good because it's a little cold in Maryland today, so it's wonderful to be in Fort Lauderdale.
Well, we're glad to have you. Just as a reminder to our audience, because you have about 42 degrees here, you have degrees from every country in the world and everything else, but give our audience, just to refresh our memories, a little bit of your background and introduce yourself.
Gosh, it gets tougher by time. But I went to medical school, and in medical school, I decided after medical school I was going to probably verge into sciences. So I started off doing a master's degree, a master of philosophy degree in statistics and computational math. Then after that, I went and did a doctorate degree. That doctorate degree was done while I was at Oxford University, and that was in psychopharmacology. And if I hadn't had enough punishment, I did another doctoral degree, also coming out of the University of Glasgow. And this time I did it in neuroscience and molecular genetics, and also aspects of brain pharmacology. So I've been in school a long time, and it feels I never left school. So I'm sure my mum must be proud.
What is the favorite thing that you do now professionally?
Well, I think the most fascinating thing is being able to go into work every day and talk to really bright people. The Brain Consortium, which was really the genesis of what Dr. Albert Rees put together, a very clever man and our dean, was to bring together a lot of the brightest and best brains in neuroanatomy, in neurosurgery, pharmacology, physiology, pharmacology, to form this consortium in which we could come up with some really big ideas and pursue them, just like the Moon Project or a large project that would actually help to cure brain diseases. Most people don't talk about curing brain diseases, but I think we're getting to the point where we should really start thinking about curing brain diseases rather than just delaying their onset or providing some kind of management of their treatments.
And it's interesting because when we talk about brain disease, it's one of the things we're trying to do at Different Brains is to get everything under one roof, which you seem to have done, because it's not just the neurological issues, it's not just the developmental issues, it's not just the mental health issues, it's everything from autism to Alzheimer's and all brains in between. And you have a handle on that, and you see the commonality in the approach to much of this.
Yes, well, I think one of the interesting things that has emerged as we have understood neuroplasticity more is that the borders between what most people call physical versus mental disorders in the brain are actually quite intertwined, and they tend to be co-localized. So one of the analogies that I gave in our last meeting was of the guy who had a punch on his head, and that the swelling of the brain could be due to why the person became depressed. Well, it's also possible that the psychological effects of being punched in the brain are pretty negative, and somebody wouldn't want to have that happen to them again. But it shows you how intertwined they are, and they're intertwined in so many ways. The most important terms of the intertwining in recent times has been all the work in pain and addiction. You know, pain and addiction are represented by areas of the brain that are sort of co-localized. So it is not unusual for somebody to have a painful condition, be given too many opiates, and become addicted because they're represented in the same part of the brain.
Now you have invented and patented medication approaches to addiction. Could you discuss that a bit?
Yes, this is really some really intriguing work, if I may say so myself. And it started off in a small room at Oxford University where I was walking down the corridor. And at Oxford, the professors just come and pluck you to do things, so I was found wandering around a corridor, and I was asked what I was going to do with my life. And I said, well, I was going to do pharmacology here. This is what I'm here to do. I was told, well, you can't do heart. You've got somebody who's going to be really good at that. You can't do affective disorders. We've got somebody who's great at that. Bankole, you're going to become an alcohol expert. So what you need to do is to think about your project and come back in about 2 years with your PhD. And your job is to find a cure for alcoholism. I said, gosh, thank you very much, sir. And so
That'll teach you to go wandering down the halls.
and tell them to wandering down the halls. And so after that, I went back to my room and I said, gosh, how am I going to do this, And so I'd read some ideas that there was this large emphasis on serotonin in the brain, and there'd been some initial studies done on serotonin in the brain. At that point in time, it had 9 receptors. And I was, at that point in time, saying to myself, gosh, I can't study all of these. I'm going to be here for about 100 years. I'll never get my degree. They're going to throw me out long before I get anywhere. So I had read some work on this receptor called the 5-HT3 receptor, serotonin 3 receptor. And this serotonin 3 receptor was fascinating because it was the only one that was a ligand-gated ion channel, which means that it took fast impulses. And if you see when people drink, even as they raise the glass to their lips, they already begin to feel the effects of alcohol. So I said, that could be something really fascinating to study. And so I started studying the 5-HT3 system, basically on a hunch. And I remember my proctor coming back in about a week or two and saying, what are you working on? I said, this 5-HT3 system. Well, that's not a bad thing, my friend. That's not a bad thing. Go ahead with it. And do you know the dose of the medications that you're going to try? And we're going to start this, first of all, in humans in our lab. And I said, and I have no idea why I said 4. I thought 4 was a good answer, so I said 4. And I was so pleased he didn't ask me for what. And so I presume he thought I meant 4 milligrams or 40 milligrams, but he didn't ask me, so it was great. So we started off the experiments, and it's ended up being 4 micrograms per kilo twice a day. But what we found was when we brought in some individuals we actually used firemen and policemen who like to drink heavily in England. Maybe I shouldn't be saying that on camera, but we bring them in, we gave them this drug called ondansetron, and goodness me, they could refuse alcohol. This is very interesting. I was then recruited to come over to the United States, and I was very pleased to get a large grant from the National Institutes of Health to actually study this ondansetron. And the idea I had was very simple. And I would say I spent a lot of time in bars in England, but it's very obvious to me that there are some people, when you go out drinking, after a few drinks, they're extremely happy, and a few more, and they're about to quarrel and fight with people. And then another set of people who are a little bit more depressed, a little bit older, who, when they drink, they get more mellow. And so this classification of 2 types, of maybe one that is an alcoholism driven primarily by impulses versus one that is more driven by affective mood disorder, was the idea that I had. And so we did this very large study of over 300 patients, and by and large we got the individuals who were these early onset individuals to be able to reduce their drinking dramatically with ondansetron. Strangely enough, the people who had the late onset, who were more depressed, they didn't get better at all. And what that meant was that there was a very specific effect of the drug on certain types of alcoholism, but there wasn't an effect on other types, which meant that there was probably a genetic basis. And so the story continues, and I took these results. They were published in a big journal. I can't remember. I think it was either Lancet or JAMA. And I decided that what I was going to do was I had to find a genetic basis for this. But the problem arose again. You know, remember I'd come to this with some serendipity, and we had tried this. So again, I said, well, let's try looking at a couple of molecular probes in the serotonin system. So I came up with this long, short examination, which had been shown in other studies by people to have some biological differences. And so we tried that in a prospective way, dividing people by genetic profile. And guess what? We found that these individuals with these long alleles who basically have an interaction between the allele and certain parts of the brain were the ones that responded to ondansetron the best. And we've expanded that work to show that there's now a 5-panel system of genetics which affects about 33% of people who drink, for which ondansetron is highly good at reducing the desire to drink and the amount they drink. It doesn't work for the other 67%. But here's the fascinating thing about this. This pharmacogenetic panel can be done by taking a blood test. And also, it can be a biomarker for drinking. So in the future, if this drug is used this way, not only can you be given the drug, but you don't need to ask someone whether they're drinking or not. You can take blood samples, you can look at their mRNA, you can take pictures of the brain, and you can tell whether they're drinking. And so it takes the whole technology of alcohol treatment from one in which somebody is saying, well, did you drink 5 drinks a day or 10 drinks a day or 20 drinks a day? And there's this argument. You can just say, I'm going to take a blood test, I'm going to do a brain scan, and I'll tell you how you're getting better. And so that to me is the science of now, the immediate now, and the interim now into the future. And as we know more about molecular genetics, we are going to be able to find other drugs that will affect the other 67% of individuals. One of the final anecdotes to this story is that this genetic pattern is very interesting. So this combination is very low in Asians, it's very low in Japanese people. It's roughly about 3-4%, these alleles. So, and that might help us to also explain why some Asians have a lot of protective factors as well against drinking. But it's very high in Americans, about 33 to 36%, but it's extremely high as you go towards the Nordic countries like Russia and Scandinavia, in which the rates are now about 50%. So they have a different type of genetic pattern that propends to drink.
Would that in any way be related to the respective, you just mentioned several geographic locations, to their respective diets when you get into the gut-brain interactions and the genetic interactions therein? Do you suspect any relation to that or not really?
Wow, you do ask some great questions. So, yes, I do, but let me answer the question in 2 ways. One of the things that's very good about serotonin is it's the oldest monoamine in the brain. And therefore, there is almost an ancestral way of tracking people as they've moved out of the Olduvai Gorge in Africa and they've spread out into Europe. And so you can see that with that migration, you can also look at the migration and how those traits are actually exhibited. And I'll just finish off this anecdote by telling you a small story. I know you like so I did my doctorate in Oxford, shared a room with a guy who was from Denmark. So I used to call him my Viking friend. He actually liked drinking. So one day so I feel that at some point I ended up going all the way back to my Viking friend saying, and trying to understand why the Vikings might have been quite the way they were in, like, you know, in historical lore of drinking, but that's probably just an aside. But the gut brain is very important because we did not understand for a long time how the gut and the brain can actually be connected. But a lot of serotonin in your body actually sits in your gut. It doesn't sit in your brain. But we now know that you can get signaling of these neurotransmitters in the brain by various mechanisms, and they affect the brain in different ways. And the important thing about alcohol is alcohol seems to affect specific parts of the bowel very differently. It doesn't affect just the large colon, it affects the small intestine. And we've been doing some really fascinating experiments now at the University of Maryland, trying to pinpoint why that is exactly and why there are specific genetic clues all the way in our gut that will tell you why these drugs might be particularly useful to reduce alcohol drinking. So this story is nowhere near ended. We may find out that maybe the effect are on specific gut microbes or specific neurotransmitters that are being modulated in the small intestine, and these are having an effect in the brain. And like every theory, maybe the theory has to be modified with time.
You were part of the team that won Emmy Awards for the HBO Hallmark, the HBO featured documentary, Addiction.
Yes.
Share with our audience your involvement with that and what that was like.
Oh, that was a fascinating project. And it was watched by about 27 million Americans. And I was glad to be included in the program because someone had heard about this work we were doing on another medication called topiramate. And so the producers said to me, they said, Professor, we are not going to allow you to choose your own patients. We're going to find you a patient, and we're not going to find you a patient in the same town because we don't want you to be able to influence this patient. So they found two patients, and one of these patients had to be brought to us by limo. I have no idea how much that cost. I don't know where he lived. And I said, only need to be able to give him the medicine and meet him for 15, 20 minutes. They said, 15 minutes? Just 15 minutes? Just 15 minutes. That's a long time. They said, a day, no, a week. And so they brought on these folk. They filmed them at home. They filmed them in their background. And then they filmed them going through the transition. They only saw me for 15 minutes. They put a timer on it. And happily for them, and I suppose luckily for me, no, I'm just joking. I did expect the medicine to work very well. They did very well. Their lives were transformed. And I think that this was part of a watershed in giving people hope that the treatment of alcohol is not futile. The problem which practitioners have in treating people with alcoholism is that individuals turn up 15 to 20 years too late. But it's really a very treatable disorder in a lot of people with the right medication in the right hands, with both behavioral and the right pharmacology. And it's actually quite a crying shame that a lot of people do not have access to treatment early. Treatment should be started at the level of the family practitioner, not wait 15, 20 years when the person has lost their job, their marriage, or their friends. It should start when the person starts to drink excessively.
Now, have you been getting pushback in the similar fashion where the natural medicine people fight against the traditional medicine people instead of getting together for integrative medicine? Do you get pushback from it's all behavioral versus any kind of medical approach where you say, look, let's give the medicine and let's take the behavioral approach and let's combine the best of both worlds for the benefit of the patient? Are you getting pushback from, say, the 12-step community or, others?
Well, I get pushback. And the good thing is, as a scientist, it's always good for someone to challenge your ideas. And the best thing about science is that you can run an experiment and see whether you're correct or whether they're correct. We ran there was a very large study run by the National Institutes of Health called Combine. And that looked at both naltrexone and camprosate with various types of behavioral treatment, including one cell which is called cell 9, which individuals got every behavioral and psychological intervention that they wanted. You wanted family therapy, you got it. You wanted some kind of cognitive behavioral, that was thrown in. Some motivation, you got thrown in. So you got mega therapy in cell 9. And the others received medication and light behavioral treatment, motivational interviewing. And guess what? The individuals who had the mega therapy in cell 9 had the worst outcomes. And the individuals, even individuals who received placebo and a brief intervention, actually did slightly better than the individuals who had the mega therapy. And to me, it's not that doesn't tell you that behavioral treatments don't work. What it tells me is that behavioral treatments have specific ways of working, just like medicines do, and you can get an overdose of psychological treatment, just like you can have an overdose of a pharmacological treatment. And overdosing people on therapy doesn't help them very much. And this idea of matching the right amount of psychological help with the right amount of medicine is really, I think, very much a key to getting the best treatments. So I want to readdress your other piece about behavioral treatments in a different way, and the pushback that I sometimes get, or often get. Alcohol and the alcohol disease is primarily a biological disorder. We now know that it's almost 60% of the capacity is inherited. So about 40% of it is, if you like, non-biological or environmental. But even those environmental factors affect the brain because they modify the genes in the brain, and they also create different expression levels of an appreciation for alcohol. So here's the way I would put it. If you were dropped into a desert and you were thirsting for water, obviously, just like I'm thirsting for water now because I've got a bit of cold. And you came upon this oasis, and this oasis was full of water, but the water was poisoned in some way. You knew it was poisoned. And you knew that drinking this water was going to kill you, but you're still very thirsty. And the thirst is your alcohol. Well, you might be able to resist for a day or two, but if you're dependent on alcohol, then you're going to drink that water and it's going to kill you. And so the biological compulsion is very high. The other piece to this is we know that people who have purely behavioral treatments, they relapse often and they tend to relapse very quickly. So up to 70% of people will relapse in 6 months. And that is a pretty strong relapse rate. So having a medication and a behavioral component is the best way to ensure that you actually get adequate treatment. It's really a shame that almost 90% of people in the United States who drink excessively don't get treatment. And of those 10% who get treatment, less than 10% of those get a medicine. That is really too bad. That is really not optimizing medicine, and we haven't probably done a great job of educating the public to say this is a treatable condition. It can be managed just like if you have heart disease or blood pressure or diabetes, and these treatments should be available to your doctor.
How can our Different Brains audience learn more about you?
Well, gosh, there's a lot about me already on various websites, but primarily going to the University of Maryland website, the School of Medicine website. They'll be able to get a bio of my work, the things that I do. Hopefully they will also take a look at the other members of the Brain Science Research Consortium unit, a group of very talented and very clever scientists at the University of Maryland, and see what they're doing. We're doing some fascinating work on focused ultrasound, which are going to be able to stimulate parts of the brain to be able to ameliorate various disorders. It's being used for the treatment of neurological disorders at the moment, may be useful for treatments of cancers, be able to be useful for the treatment of affective disorder, maybe even addiction. We're doing some fascinating work on the gut-brain axis to look at schizophrenia and alcohol to determine whether we can change these microbes in a way that will actually be, if you like, healthy choice treatments for alcohol and other mental disorders. There's just so many fascinating things going on, and every day is just a thrill. Sometimes it's exhausting because I have to keep up because there's so many brilliant people in the room. I have to do a lot more reading than I probably used to, but I should probably not admit that. But I have to do a lot more reading to try to understand what everyone's
Well, I got to tell you, it's a great thrill for me to be able to learn all of this from you. I mean, you've devoted your whole life to this, really. And you're always at the cutting edge. And what you've done and what the University of Maryland have done, and again, getting everything under one roof with the Brain Consortium, is nothing short of epic and very, very much needed. It's been a pleasure having you back. We've had the pleasure again on another episode of Exploring Different Brains to have my friend Dr. Bankole Johnson from the University of Maryland, one of the world's great addiction experts, if not the addiction expert, and also neuroscientist, doctor. He does it all. And one of the leading authorities about the brain in general. And thank you so much for being here today.
Thank you, and I appreciate your invitation, and it's wonderful to see you in person. Thank you for having me on your show.
Exploring Different Brains is a production of Different Brains, Inc. For more information, visit us at differentbrains.org.